Good morning, folks. Today is Unit 5, Day 1. And this unit is all about exponents and logs. So today you're going to review/learn a whole bunch of exponent rules that you might or might not remember from Algebra 1, so we'll start fresh. I think there are 8 of them total, and I'll try to move quickly through the ones that you probably remember, and then we'll slow down on the ones that you need to do. First one is when you're multiplying like bases, you of course add the exponents. This is like the generic rule. So if you need to write it in words, you would write, when multiplying like bases, add the exponents. I don't know if you prefer it like that or like this. This is just like the generic rule. So if I have something like 3x to the 4th times 2x to the 3rd, my answer here is 6x to the 7th. These are not the bases, these are coefficients, so those really do multiply. But here, x to the 4th and x to the 3rd, when you're multiplying, will make x to the 7, not x to the 12. So think about what it is. It's x times x times x times x, 4 of them, times x times x times x, 3 of them, the total 7 of them, and that's why you end up adding when you're actually multiplying. So you don't have to write this out, but you certainly could if you were unsure. Suppose you have something like 6 to the 4th times 6 squared. Now the base is 6. That's not a coefficient now, that's the base. So my answer here would be 6 to the 6. That 6 is the base and just moves along just like it was an x. All right, number 2, when you are dividing like bases, you, of course, subtract the exponents. So this is rule number 2. Suppose you have 14x to the, 12 divided by 7x to the 8. Again, these are coefficients, so they really do divide. That would make 2. But here, these are the like bases, so here's where I subtract the exponents. My answer here would be 2x to the 4th. Let's do one more. Suppose you have x to the 10th divided by x to the negative 2. Remember, you're subtracting, so it's not 8, it's 10 minus a negative 2. 10 minus negative 2, this will actually be x to the 12th. And we're going to talk about negative exponents in a minute. That's one of the rules. And then the last one, let's suppose you have x to the 2 divided by x to the 6. Again, if you use the rule, which is to subtract, the answer would be x to the negative 4. If you want to think of x squared as just x times x, so this is like the same as that, and x to the 6 as x times x times x times x times x times x. Of course, for every 1 and 1 I can cross out because anything over itself is 1. My answer is 1 over x to the 4th. There are 4 x's on the bottom. So this is an equivalent answer. These are equal to each other. Either way is okay. To kind of take 2 off and leave the more on the bottom, or to just apply the rule. Okay, number 3. Number 3 is a power to a power. When you have x to the a raised to the b, you multiply those, x to the ab. So an example of this would be like y to the 6th cubed. My answer is going to be y to the 18. If you want to think of what this is, remember we always said you could write it out. Anytime you have something squared or cubed, you could write it out. So it'd be y to the 6 times y to the 6 times y to the 6, right? Because there's 3 of them because of the cube. And then we're using rule number 1. When we're multiplying like bases, we add the exponents. That's another way to do it. But you can just remember that these guys multiply. Okay? They multiply when a power is raised to another power. One thing to sort of be careful of, and let's just show 2 of these examples. Like suppose you have negative 2 quantity squared, and then you have negative 2 quantity cubed. When we do a negative times a negative, we end up with positive 4. Here when we do a negative times another negative, raising it to the third power, we end up with -8. The same is true as if you have variables in there. So if I have negative x squared, my answer here is x squared. If I have negative x raised to the third power, I get negative x cubed. So when we have a negative here, and it's raised to an even number, this is positive. When I have a negative here raised to an odd exponent, the answer is negative. So if it was raised to the fourth, of course, a negative times a negative times a negative times a negative 4 times would make a positive answer. If it's odd, it makes a negative answer. All right, rule number 4 and rule number 5 are, again, kind of common sense, but let's just write them down anyway so you've got everything in your notes. Xy to the n is the same as x to the n, y to the n. So what that means is if you have a bunch of stuff being squared, make sure that you square all the pieces that are inside the parentheses. So suppose I've got 3b raised to the third power. This is actually going to be 3 to the third times b to the third. My answer here will be 27b cubed. So this 3 exponent has to hit everything that's inside. Let's do one more. 2h to the fourth squared. Now we're kind of combining rules. I'm going to go 2 squared, and then here, h to the fourth squared, this was our rule number 3, these guys multiply. So my answer here will be 4h to the 8. You certainly could write it out and write 2 squared, and then h to the fourth squared. And then you could write that out if you needed to. 2 times 2, h4, h4, and then just do 2 times 2 is 4, h4, h4 is h8. So this is an alternative if you would like to see it written out. All right, we're moving right along. Rule number 5, really similar to 4, it's just a quotient instead. So if you have 2 different things that are dividing raised to a power, again, it's just like raising each piece to that power separate. So if you have something like 2/3 to the third, it's just like 2 to the third over 3 to the third. It would be 8 over 27. So just make sure that this exponent hits everything inside. Let's do one more here. I've got 2r over like t cubed squared. So again, it's important to either write it out twice or just to remember that this squaring happens to all of the terms inside. So it's going to be 2 squared, r squared, and then t cubed squared. So this 2 to the second power is 4, r to the second power is r squared, t cubed squared is going to be t to the 6. Okay, rule number 6. Anything raised up to the 0 power is 1. You may or may not have heard that before. A lot of times students want to say anything to the 0 is 0, but actually anything to a 0 is 1. So if you have something like 12x to the fourth divided by 3x to the fourth, and you go back and think about rule number 2, I'm going to divide right here, right? 12 divided by 3 is 4 rather. And x to the 4 over x to the 4, remember anything over itself is 1, but suppose you want to use that rule of division. When I divide like bases, I subtract the exponents. X to the 4 minus x to the 4, 4 minus 4, it would be x to the 0, which is the same as just 1. Of course, this is 4, because that and that make 1. So you could do this, but really knowing that's why that happens, because anything over itself is 1, because when you subtract, you end up with a 0. And then also to be careful that you understand the difference between this and this. Anything raised to the 0 is 1. So when I have a whole quantity of 3x to the 0, this answer is 1. But here, the only thing being raised to the 0 is the x, not the 3. So this is like a 3 times 1. This answer would be 3. So the parentheses really do make a difference here. Okay, we have 2 rules to go, and these 2 I'm pretty sure are new. So far, a lot of this may have seemed like review or something that you kind of knew from exponents from before, but I think these last two are new. All right, rule 7 is when you have something raised to a negative exponent, it's the same as 1 over that exponent to a positive. So what a negative exponent does is it takes what you have here and it flips it over and makes the exponent positive. So the reason this went over 1 is because this has an invisible 1 underneath. So it makes this thing flip over. A minute ago in the division rule, we said, what if you have 2 to the 2 over 2 to the 6? And we said the rule for this is if you subtract the exponents, you get that. And then we said, or you could think of it as this. Do you remember we just did this a minute ago, right? You might or might not have written it down in your notes then. If I cross out the 2 and the 2, I would have 4 x's and they're on the bottom of the fraction. It's that. These answers are completely equal or equivalent. So a negative exponent is the same as it being underneath the fraction bar. It's the same as the reciprocal. So suppose I just have 2/3 to the -1. That is the same as 3 over 2. It makes whatever you have flip over. Let's go again. Suppose we've got 2x to the -3. Again, the 2 isn't raised to the -3, just the x's. This answer would be 2 over x cubed. So the negative exponent just takes whatever you have and flips it upside down. It makes it go underneath the fraction bar. Now let's get tricky. I've got 3x squared to the -2. This is a combination of several rules that we had, right? The quotient, the thing applying, and the negative. So you've got to do all these different things. I would probably take care of the negative first. The negative exponent just makes whatever we have flip over. So I'm going to flip it over, and now it's just raised to a +2. So all the negative does is flip this. And now this squaring, again, will happen to both of those parts. My final answer here will be x to the 4th over 9. Let's do one more. 6a over b raised to the -2, let's say. Actually, that's fine. So again, this negative just makes this thing flip over. So my answer will be that over that squared. And then we'll square all the pieces. B squared over 36a squared, and that would be my final answer there. Negative exponent does not ever make your answer negative. So I'm going to squeeze one more right here. Sometimes when students see this, they go, oh, I know, -25, right? I bet it's -25. But it's not. The negative only just makes whatever you have flip. So what's under this invisible? A 1. This answer is going to be 1 over 5 squared. My answer here will be 1 over 25. So of course the calculator, if you typed this in, would give you this, but a lot of times students just assume when they see this negative that it makes the answer negative. It does not. It just makes your answer a fraction. Okay, we have one more rule, last rule, number 8. Also new, I think, also something that you did not have before. And this is all about a fractional exponent. If you have x raised to the p over q, it's the same as doing a q root of x to the p. So a fractional exponent does two things. It takes a root and raises a power. The bottom part of the fraction is the root. The top part is the power. And it's like a two-step thing, and it really does not matter which part you do first, but I almost always take the root first. So if I have 8 raised to the 2/3, there's two things that are going to happen. We're going to take a cube root of 8. So this bottom part just becomes the root. Cube root of 8 back from unit 2 is 2. If you didn't know that, you could type it in your calc. And then this top part becomes the power. 2 squared, my answer here is 4. So the bottom part is the root, the top part is the exponent, and this is your final answer. Let's go 32 raised up to the 2/5. Again, of course you could type this in your calculator, but I would really encourage you not to do so. You need to understand what the different parts of this fraction are doing. And if you keep typing this into the calculator on day 4 when we go to learn logarithms, you are not going to really understand what's going on here. So it's the bottom part makes the root. So I want to take a 5th root of 32. And again, this is from our chart when we did the perfect cubes, perfect fourths, perfect fifths in Unit 2. A 5th root of 32 is 2. And then we're going to raise it up to this exponent. 2 squared, again, it's just a coincidence. My answer here is 4. So this part can go in the calc. This part could go in the calc, of course, if you needed to. But try to get into that idea of the 2 steps and not just typing the original in. All right, let's make it super tricky. 64 up to the negative 2/3. All right, so now I've got a fraction and a negative, a combination. But remember, the bottom part is the root. So I want to take a cube root of 64, which gives me 4. And then I want to raise it up to the negative 2 exponent. So this top part is exponent, bottom part was root. And again, what does the negative do? It just makes it do this. My final answer here is 1/16. All right, I really think this will be our last one maybe. I'm getting as tricky as I can get. 4/81. Oh shoot. Yeah, it's okay. I was going to say there is one more thing, but that we'll knock it out right here with all the same. All right, so it's a fraction, and it's a fraction, and it's a negative. But remember, when you've got a fraction, a division, you need to apply it to both parts, right? That was rule 5 or 4, whatever it was. And the bottom part is the root, and the top part's the exponent. So we're going to take just a square root of 4 and a square root of 81, which will give me 2/9. And then we're going to apply this as the exponent. So this is my exponent. So I'm going to raise all that to the negative 1. Negative just makes whatever I have flip around, so it's going to be 9/2 raised to the 1. My answer here is just 9/2. So when I just said, oh shoot, there was one kind of important thing, so let's put a little star here and just hit one more thing. If I have 25 to the 1/2, okay, so not a fraction, but just a regular number to a 1/2. Remember, the bottom part's the root. Square root of 25 is 5. And then I'm going to raise it up to the exponent of 1. 5 raised to the first power is 5. So what is 1/2? A power of 1/2 is the same as doing just a regular old square root. So an exponent of 1/2 is the same as taking a square root. So if I say 9 to the 1/2, it's 3, because the square root of 9 is 3. It's the root, and then the exponent being a 1 means it's not going to change anything. And that's kind of another sort of important fact to know. All right, so a whole bunch of rules for you for today. You had a worksheet that went with today. There are 2 questions that need to be X'd off. It's number 6 on the left side on the A column, and number 3 on the right side on the B column. Those 2 things that have an equals in them, the exponential equations, that's what we do on day 2, so you don't have to do those. But if you are going to try the worksheet on your own, now would be the time to pause the video and try it. And then in 1 minute, I'll put the answers underneath. Now, I didn't show work here. I just kind of wrote the answers clean. So if you don't get them correct, and you look back at your work and you are not sure why the answer is what it is, then please make sure that you come in and ask for help, okay? Just because you get them wrong doesn't mean you need to say like, oh, well, you know, I don't know what I did wrong. You want to get that clarified, or ask as soon as you come to class or an AA or something like that. All right, thanks so much, and again, pause now, and answers are on the way. Have a good night. I'll see you tomorrow.